Alright, today we'll continue where we left off on Saturday with trigs, of course, trigonometry. And we already established what trigonometry was, right? We established that it was the geometry of triangles, finding unknown sides and unknown angles in a triangle. So, a quick recap. We we split trigonometry into two categories, right? Dealing with the right angle triangles and non-right angle triangles, right? But we later on we will move on to the non-right angle triangles, and we further split up right angle triangles, the analysis of right angle triangles, into some smaller categories. Now, Saturday gone, we dealt with Pythagoras' theorem. I don't know if it's spelled correctly again, but who cares, right? We dealt with Pythagoras' theorem, and we established that Pythagoras' theorem only dealt with the sides, finding the sides of a right angle triangle, right? The lengths of sides. Whenever we have a right angle triangle and all they gave us was the sides of a triangle, we would run to use Pythagoras' theorem. That was what that was for, the theorem of Pythagoras theorem. Now I label the sides differently, but if we can remember, it doesn't matter how the sides are labeled. Once we remember the concept behind coming up with the theorem itself, we had called the hypotenuse A and the other two sides B and C. And we had stated that Pythagoras' theorem was A squared is equal to B squared plus C squared. But it's a quick run through, right? So I expect you to know this from last class. A squared is equal to B squared plus C squared. And this is Pythagoras' theorem. And we dealt with that. And we also dealt with the notation of the triangle. We said that A was the hypotenuse, right? And B and C would be the opposite and the adjacent, but that can be interchangeable. But B and C could be the opposite and the adjacent, but that can be interchangeable, right? Now, that's the basics we went through. Again, we're dealing with the analysis of right angle triangles only. So Pythagoras' theorem could only be used for a right angle triangle at this stage for a right angle triangle, right? Now it's important we get familiar with the hypotenuse, the opposite, and the adjacent sides, because what we're going to move on to, we're going to be using those terms a lot, right? We can now be moving on to trig ratios, right? Trigonometric ratios, you hear it frequently, trig. We don't say the whole word trigonometric, we just say trig for short. Again, right angle triangles alone, we're using these for at this stage, and trig for short. And if you notice, I have a right angle triangle here, and I labeled the hypotenuse H, one the sides opposite and the other side adjacent A, right? And there's a reason for that. Now, before, I had stressed that Pythagoras theorem was only used for when you have right angle triangle and they were given the lengths of the sides alone. Now, when angles become involved, right? This is our angle. This symbol, let me draw it a bit clearer. Something looking like this. People draw it differently, right? Basically like that. Something like this, something of this sort. Depending how fast you're drawing. Theta. This is just one of the many symbols used to denote an angle. Just like how you use x in algebra to denote an unknown value of something, theta is used to denote unknown angles. Angles you seek to find. Now, when unknown angles, I mean, not only unknown, when you're given angles in general, in a right angle triangle. We ask to analyze it. Analyze meaning find the length of the side, find the magnitude of the angle. Let trig ratios come to mind, because this is what you use trig ratios for. Find when angles are involved. Use trig ratios to find the magnitudes of angles, also the length of sides, right? So if you're given a question where is the right angle triangle, and you notice only lengths of sides are given, and you're asked to find another side, you can use Pythagoras theorem, right? Again, if you're given a right angle triangle and they give you lengths of sides and also an angle, Pythagoras theorem must not be the only thing that comes to mind. Trig ratios. Maybe you can use the trig ratios to find what they're looking for, right? So, there are 3 trig ratios. So, the first trig ratio we look at is sine. Now, sine, S-I-N-E, S-I-N for short. Yeah, sine or sine for short is the first one we look at. Now, on the calculator, you'd only see at least for the sharp, you'd see the short S-I-N for sine. Now, what is sine? Furthermore, let me list all 3. Sine, cosine, short cos, cos, and then tangent. You'll most likely see the short versions on the calculators, right? And tan is sine for short for tangent, right? So sine cos tan. That's what we generally hear, sine cos tan. Now, what are these 3? What is sine? What is cosine? What is tangent? What exactly is a trig ratio? Now, these are operations, right? A mathematical operation. What is a mathematical operation? I'll give you one we're familiar with. For instance, we have a value 3. That's a number. It's a value. 3. Could be 3 anything, right? It's just a figure 3. I could write another value, 4. Now these are just values written on the board. Now, a mathematical operation would be plus in this case. It basically tells you what to do with a value. In this case, a plus sign. This is a mathematical operation you know about. Tells you that, okay, I'm adding 3 things to 4 things. It operates on the values presented. 3 to 4 equal 7. Subtraction is the operation. Multiply tells you what to do with a value. And such. Sine, cosine, and tangent are operations. Now, addition, subtraction, multiplication, those things, those operate on an ordinary number 3 and 4, right? Normal whole numbers and so on. These operations, on the other hand, operate in angles, right? These operate in angles. This tells you what to do with an angle. In this case, theta, right? And as we move along, I can show you exactly how we operate in the various angles. It operates in the various angles. Now, an example. First, then we have 30 degrees. This is an angle. Now, I'll expect you to know, but the little circle at the top, basically, that is a degree, the symbol for a degree. Now, at this stage, we will be only looking at degrees. Later on, you might be looking at radians, I don't know. Degree, that's an angle. Now, as it stands alone, there's just a random angle. But when we include, say, sine in front of the angle, so you're basically doing something angle. When you operate at an angle, just like how when we operated on 3 plus 4, we can get a value of 7. When we operate in a sine, we can also get a value 0.5. Now, how exactly we get 0.5, at the C-sec level, you won't need to know that. But when you operate on a sine 30, you use your calculator to get these values, obviously. Sine 30 would give you a value of 0.5. And you do this for, you can cos the angle also, right? Cos the same angle 30 degrees, and not just 30 degrees, you can do it for on any angle, well, the angles that would be given in a triangle, and you will get 0.866. We get the gist. Same thing, if you tan it, you get a value, etc. These cos, sine, and tan does that. It gives you a value. It operates on an angle. Now, how do we apply these ratios to a right angle triangle? Alright, how do you apply it to a right angle triangle? Now, we have established, not me, the mathematicians of the past, have established a relationship between the operation and the angle. So we have established that the angle is theta, right? So we can do each of the operations sine on theta. Well, again, imagine theta is x. Theta can be any angle. We're just using this to derive because you have to remember the formulas, right? And the hardest thing about this is, well, for me, was remembering the formula. You can cos in theta, and you can tan the theta. Now, we've established a relationship between the operation, the three different operations on this angle, and the sides of a right angle triangle. Now, this is where the importance of knowing, well, the hypotenuse of a right angle triangle remains the same. If you can remember, the hypotenuse is the side opposite of a right angle. We already went through that this symbol is the symbol of right angle. It's the side opposite of a right angle, of the right angle. And that remains the same because a right angle doesn't change position. But the opposite and adjacent, those sides are interchangeable depending on an angle given. Now in this case, we're given the angle theta. For instance, we go back to the hypotenuse. The hypotenuse is opposite or over. If you look here and you look over this side, it's opposite. The hypotenuse is opposite this right angle. So we're going to use that same explanation to determine, well, I already have it labeled here, which side is opposite of this angle. Now we're looking at this angle theta. You look over, I don't really have to explain opposite. Somebody's opposite is over from you. This side of the triangle is opposite of the angle given, theta. And if you can identify the opposite, we already know hypotenuse opposite, the other side automatically becomes adjacent. So we get that opposite of the theta. Now, just I'll give you another triangle where I change the position of the angle, and of course the opposite will change, etc. Depends on the orientation of the triangle. Now we establish a relationship between the ratio, the operation, the trig ratios, and the sides of a triangle. So we begin with sine theta. Now the relationship was, if we have a value for theta, if we operated on this value, sine this angle we were given. Now if you're last, when I work an example, you get it. So if we're to operate on some angle theta, the value would be the same as if we had divided the opposite side of a right angle triangle, the length of our opposite side, if we had divided it by the length of our hypotenuse. Example. So we'll use this as an example. Now this is just a random triangle I'm using to explain the concept, right? Now remember, if we use our calculator and we put in sine 30 degrees, we'll get 0.5 if you use a calculator. Now the relationship between the ratios and the sides is kind of, so you don't really have to use a calculator to get a value. Now we can put in calculator to get a value of 0.5. What the ratios are saying, sine of whatever angle, and would have been the same as if we had just divided or opposite. Now remember, I guess this is a big jump from what we're dealing here. This 5 cm is opposite of the angle given. It's the same as if we had divided our opposite, the length of our opposite, by the length of our hypotenuse, 10, which is the same value as 0.5. And that's basically all this here does. It gives us relationship between operating at whatever angle and the lengths of sides. And that will basically do for the other ratios. If we were to cos an angle, the value we would get would be the same as if we had divided the length of the adjacent side by the length of our hypotenuse. And finally, if we tan an angle, sorry, I forgot the angle theta, right? Let me just slip that in. If you had tan an angle theta, tan the angle, the value we get would be the same as if we had divided the length of our opposite side by the length of our adjacent side. Now, knowing which sides to divide has often been a problem. Well, for me it was one of the hardest things to remember. Okay, if you're sine something, it would be the opposite divided by the hypotenuse. If you're cosine something, it would be this divided by that. So people have come up with some creative ways to remember it. Now, the more you practice, the easier it is to remember, right? But they would say sine is equal to opposite over hypotenuse. And sine is equal to opposite. So I guess we all would have heard from the various math teachers their way of solving it. Some not as not as family friendly as others. Some may say S-O-H, ka, toa, sokatoa, sokatoa. The my teacher would have said some old, they put a word for each letter. What scholar? Can't even remember. Some old horses can always hear their owners approaching. Now, you can come up with your own once you remember them correctly. To remember it. Right? Now we go into how we use these ratios to actually solve a problem. Now, before we actually go into these examples, I wanted to further concrete opposite and adjacent sides, right? So the two examples are there. So the triangle we used was, I think I remember this. Let me say theta, opposite side, adjacent, hypotenuse. And we said that the opposite and adjacent would depend on where the angle was. So in this case, angle. Well, now we always know the right angle, right? Yes, some people want to get technical and say, oh, opposite, but it's not basically where the right angle is. It's basically based on where the other angle or angles are. Now, take this here, the angles here, the opposite side will be here, adjacent here. So, not quite naturally, if the angle is to go here, the opposite, the new opposite now the side opposite of theta would be here. And this would be adjacent. Another way you can look at it, the adjacent side is the side where both angles lie on. Both the right angle, and the other angle lies on. And you can change it, for instance, in a triangle of this sort, I just change the orientation. Say we have it drawn like this. Because when they change the orientation of the triangle, people tend to get lost. So the hypotenuse is the side opposite of the right angle. So this is our hypotenuse. Now, the opposite, the angle that is given, or that the want, the side opposite of it would be here. And this would naturally be the adjacent. So let's do another. Again, it's always identifying where your angles are. Theta. The side opposite of the right angle is our hypotenuse. Right? Now our opposite and adjacent. The angle, this side is opposite of our angle. So this becomes our opposite side. Naturally, this becomes our adjacent. One more. Hypotenuse, opposite, adjacent. Right? Quite simple. Now, that was easy given one angle, but when you're given two angles, again, the concept remains the same, but you would just have to know the sides based on whichever angle you're using. Now, the opposite and adjacent would be depending on the angle you're using. Now, as you remember, the hypotenuse never changes, right? Now, we're given two angles. Now, in problems further down, you realize you have problems where all the angles are labeled. And depending on which angle you use, that will depend on your that will determine your opposite and adjacent side. What does that mean? Now, so the problem has given us angle theta. By the way, this is another symbol for representing an angle. They call it phi, right? But you don't need to know this now. They would just call it unknown angle, phi, whatever. Phi, a circle with a line drawn through it, similar to theta. Now, if we're using the angle theta, right? We'd ignore this. We're using the angle theta. The opposite side would naturally be the side opposite theta, and this would be our adjacent, if providing we are using theta. Now, if we had been using phi, the opposite side would be here, the side opposite of phi, and this would be our adjacent side. Now, it just depends on the angle. So if you see more than one angle, that's how interchangeable an opposite and adjacent side is. I hope. And depending on the orientation of the angle, the triangle, again, don't let it confuse you. Opposite and the adjacent is determined by the angle that you're using. Now we move on to working these two problems. Now we look at the first problem. Right? The first right angle triangle. Common instructions. They give you values for whatever you need to know. And the whatever is represented by a letter or symbol is oftentimes what they require you to find. Right? So in this case, we're given a side x. So we need to find the side x rather. And we're given the size of an angle, 27 degrees, and the length of one of the sides. So, common instruction, find x, solve x, you know the gist. Now, in solving this, now again, as you're now learning it, it's good to remember it in steps as opposed to just going straight ahead into which ratio we're using, etc. Now, because an angle is involved, we know we have to use trigonometric ratios to solve it, right? If I had asked you to use you can't use Pythagoras theorem to solve this, right? Because you need at least two sides. In any equation, you need at least you can only solve an equation you want to know. Anyways, that's complicated. Now, we gotta solve this. Now we need to know what ratio, etc. using. Before we go on to all that, as with any problem, as I mentioned before, excuse me, you write down what is given. Always in maths. Maths, any problem you come across, what's given here, we could realize that this 11 cm is our hypotenuse, the length of our hypotenuse. Alright, we're given the angle. On 7 degrees. The side x. Now, what side is x? Is the opposite or adjacent? It depends on our angle. We realize that x is opposite of our 27 degrees. So that side would be our opposite side. Let me write it. We write down what is given. After we do that, we need to determine which one of the ratios we're going to use to solve this triangle. Sine, cos, or tan. No, that depends on here what is given, opposites and hypotenuse. Depends on the sides given. Now we see this opposite here and the hypotenuse here, so we know we have to use sine. Now, after this is established, it becomes easy. We said that sine of whatever angle is given is equal to the opposite, the length of the opposite, x, over hypotenuse, 11 cm. Well, you don't have to put a cm, it's understood. X, and now the problem just becomes a matter of solving for x. You can type in sine 27 in your calculator. So sine, oh shucks, it's not even on. Right, sine 27. Sorry, sine 27 degrees. Now you get most values will give you a long value of this. Now, when writing the values after you sign it, use the first four, not the first four, at least four. Some people use 1 and 2. Use at least 4. How much ever you're able to write. So I will use the first 4. And of course, rounding applies. So when I sine 27, I will get 0.4539. I use the first 5 to avoid rounding. Is equal to x over 11. I basically operated it, did the operation, and now got a value. Now I'm going to solve for x. Again, transposition, you carry over the x, as some would say, and it's division over here. So when you carry it over, it becomes 11 times 0. Is equal to x. Therefore, x is equal to 11 times 0.45399, 4.99 cm. Let's say 5 cm. If you had used all the values, you would have gotten 5, right? And that's basically all there is to it. Determining what is given, establishing what is given. Given means, in this case, they give you values, and also given means the unknown they're looking for, right? Because it's quite often the unknown would be one of the sides to get our value x. Now let's work the other one. We'll now work the second problem where the arrow is pointing itself. This. Now, similar process, same process. Maths is easy, right? Our hypotenuse is 9 cm. Write that 9 a bit better. The angle given is equal to 30 degrees. And they want to know y, right? Y is the side opposite of our 30 degrees. So we are given the opposite side is equal to y. So sine of 30 degrees is equal to opposite over hypotenuse. So when you sine 30 degrees, you get 0.5. 9 times 0.5 is equal to y. So easy as that. always remember to put back a unit. Although we weren't working with it here, always remember to put it back. And that's basically it. Let's now work another example. Yeah, we now look at this problem. Again, the same steps apply. So, again, we apply what we have learned. The angle given is L. So, yeah, you can use letters to represent the unknown angles also. You theta and phi, you can also use that. Angle given is L, or hypotenuse, 13.6 cm. And this side 12.1. What is it? Is it our opposite or adjacent? It's a side opposite of our L. So it's our opposite side. Right? So opposite and hypotenuse, we have the sine. And L is equal to our opposite side, 12.1, over hypotenuse, 13.6. Now we divide these two. Math is easy. 12.1 divided by 13.6. Now again, we use 4, at least 4. You can use as much as you want, but using at least 4. 0.8897. Right, the more you use, the more accurate it is. But 4 tends to give you an accurate enough answer for CSEC level. Now, we want to find the angle L, right? Now, before we were transposing the length of a side and multiplying the examples before. Now, if we can remember from transposition, what we want is the L. So we basically have to carry over the sign, right? Now, basic recap. X plus 4 is equal to 7. X is equal to 7 minus 4. When we carry over an operation, say plus, it becomes negative. So what happens when we carry over an operation? Sine. It becomes something called sine inverse. 8897. So we carry over the sine to get L by itself. And how do we get sine inverse in a calculator? It's commonly above the sine itself. See, when you can find the sine button, you can see it in orange here. I don't know.